A topic that needs a little more practice would be this graphing of linear inequalities on the coordinate plane. Right away, I'll notice in my first example, y is greater than negative 2x plus 1. It's in the right form, meaning that y is isolated on the left. So I will start off by identifying my slope. My slope is a ratio. When it's a whole number, I just place it over 1. And my y-intercept, which is b, is equal to 1. The slope tells me I'm going to go down 2 and over 1. And my y-intercept is that point on the y-axis. Now, before I start plotting any points, I'm going to take note that this is a greater than, which means it's going to be a dashed boundary line as I'm creating the line of this inequality. I'll start at 1. There's my y-intercept. I'll count down 2 and over 1, and I'll do that repeatedly throughout the whole length of my graph in both directions. It takes a moment or two, but it tells me that this line has a negative slope, and now I'm going to create that boundary line by putting the dashed line here. For a less than or greater than or equal to, it's a solid line. When it's just less than or greater than, dashed line. Now comes the shading part. We need to decide if we need to shade above the line or below the line. We use a test point. We use 0, 0. That means that y is 0 and x is 0. And then we go ahead and simplify and see that statement says that 0 is greater than 1, which is a false statement, which means that the origin 0, 0 is not part of this. So I'm going to now shade everything in the portion or the area that is not including the origin. So you see that we have to do a little shading. Now what does this mean? That means that all of the ordered pairs in this part of the graph are possible solutions. As I mentioned last time, I'll show you that in a moment. Okay, so now let's go back to seeing how we're going to do our next problem. Next problem, already in the right form. I get my m is equal to 3 over 1. My y-intercept is negative 4. Where do I start graphing? Well, first of all, again, I have a less than or equal to, which is a solid line. It's good to, again, remember that as we're starting off. Started our y-intercept, negative 1, negative 2, negative 3, negative 4. It's a positive slope. We're going to count 1, 2, 3, and over 1. And we'll do that again, the length of the graph. And one more, 1, 2, 3, over 1. Solid boundary line. So again, not necessarily my straightest line, but we should be using rulers to do this. Okay, time to test out a point. What is our best test point? 0, 0. It doesn't fall on the line, so it's a good test point. 0 is less than or equal to 3 times 0 minus 4. Is 0 less than or equal to negative 4? That's a false statement. Once again, 0 is greater than negative 4. So now what am I going to be doing? I'm going to be shading. And this time again, I'm going to be shading away from the origin. And everything in this portion of my graph is possible solutions. And there you have your graph. I think we should do at least one or two more. Here again, already in the right form. I like when they're in the right form. I don't have to do any extra thinking or planning. I just know it's already in the right form. I identify my slope, which is 3 over 2. My y-intercept is 1. I have a greater than or equal to, which is a solid line. Just things that you should think about before you start graphing. Y-intercept right there. I'm counting up 1, 2, 3, and over 2. 1, 2, 3, and over 2. Slope is constant. And we'll go down Okay, and we'll see that it is a solid line, so I can take these points and just connect. On to the shading. Testing out the point 0, 0, it says that 0 is greater than or equal to 1, and that's a false statement. So I'll get out my highlighter here and I'll shade everything that is 0 greater than 1. That's false, so that means the origin is not part of it. Okay, I hope you're starting to see the, and again, that also means that all the points on that line are possible solutions. And there's our graph. Sometimes you'll be asked to graph constants, okay? So think about this. If y is always negative 4, y is negative 4. So I'm going to count down 1, 2, 3, 4. It's going to be a dashed line. So if y is always equal to negative 4, I'm going to have this dashed line all the way across here. Now, is 0 less than negative 4? Again, another false statement. So what will I do? I will shade everything away from the origin. All of my solutions are points that fit in the graph shaded area. X is greater than or equal to 1. Looking at this, X is always 1 right here, and it's a solid line. The full length of my graph is 0 greater than or equal to 1, another false statement. So we're looking at, I got to get a true one coming up here so we can see the difference. It's a false statement, so everything's shading on this side of that boundary line. Okay, so solid and dashed lines, shading with the origin or away from the origin. Here's one that's not in the right form, and it's good for us to practice one of these as well. I need to isolate y, so I'll get started by subtracting 3x over to the other side. And then we'll divide by negative 2. And I'll get y is, now because I was dividing by negative, I have to reverse the direction of my inequality. Let's start the graphing at positive 2. I'm going to go up 3, 1, 2, 3, and over 2. Okay, solid line. And is 0 less than or equal to 2? Finally, a true one. So that's true. That means that I'm going to shade everything that includes the origin. Well, if the origin is right here, I'm going to shade everything that has that origin, including that. And all these points are possibility as far as solutions. Okay. So here we've had a lot of good examples today of how to graph linear inequalities in two variables on a coordinate plane.